Hello everybody, welcome to my review of the VCAA VCAA VCE Northern Hemisphere Timetable Mathematical Methods Exam 1 review, and this is from the year 2024. So this is exam 1. Let's begin. The first question is a calculus question, typical starting question for VCAA. It is just asking you to factorize a function. Over here, you can see that here. I've written down here, we are meant to use product rule because the function is composed of a function x multiplying another function, which is an exponential function. So when you have a function multiplying another function to make the whole function, you differentiate it, you use product rule. Here is the working out. You just basically follow the formula for product rule, and if you happen to not recall the formula for product rule in the exam, it is in your formula sheet. So this is the formula sheet that is provided to you in exam 1 and exam 2. So even in exam 1, you can just look at the formula sheet and just follow the formula for product rule to execute this question. The second question, 1b, it is another differentiation question. This time we have a function divided by another function. So x cubed is a function and it's divided by the logarithm function. In this case, we use the quotient rule because quotient means divide. And then again, if you forget the formula, it is in your formula sheet also. So if you do memorize the formula, it is better that way. But if you do happen to not remember, then there's formula sheet. Follow the formula. Here's my working out. And then it's not just asking you to differentiate, it's asking you to substitute a value after you differentiate. So I didn't even bother simplifying the derivative because I'm subbing in e, so I just get one answer for the derivative and then substitute e into it, and then I get the answer. Also, I did not really check my responses after my first attempt. I just did it and then left it. So if you do see any mistakes here, please leave it in the comment section. If you see any mistake, please put it in the comment section. Again, I did not check my own work after my first attempt. And then this one, again, very common in VCAA exams. You have two linear equations, but it's literal equation. So not everything is written in numbers. There's another variable a. Well, I shouldn't say variable. There's another unknown, which is a. And then it says find the value of a for which there are infinitely many solutions between the system of equations. First thing we do is we rearrange both equations to make y the subject. And so this is the first equation, that's the second equation, y being the subject. And if there are infinitely many solutions between them, it means this. It means the two lines are one and the same, which kind of looks like this. If I can visualize this here, if that's the first line, if that's your first line, your second line will look like this. It will be exactly the same line. Right? That's how you get infinitely many solutions. The two lines, the equations, they superficially they look different, but they are indeed the same. If that's the case, then you have infinitely many solutions between the two lines. Okay, with that in mind, we can do some work. First thing I did was I equated the gradient because that's how you make two lines the same line. So the gradients are the same, and then I get two answers for a. A is -2 and a is 1. But my working out is here. It's a quadratic. Then I use cross method here to solve the quadratic. Second thing I need to do is I need to make the y-intercept also the same because everything about the two lines have to be the same. So the y value has to be the same. So 3 over minus a has to be equal to 2a plus 1 over 2a, which is over here. So for that, that's again a quadratic. Use cross method again. On on looking at this now, I don't think I've provided enough working out. Like the first quadratic I solve, I've got two answers. Second quadratic here, I also have two answers. I actually do have two answers here in my second quadratic, which is a equals to 1 over a as well. A equals to 1 over 2 as well, because that's this factor here, 2a minus 1. So a is equal to 1 over 2 as well. I should have shown, like, this is a 3-mark question. So for me to show full working out, I need to write down all the solutions to the second quadratic. And then I need to say I am eliminating, I'm rejecting half as my answer because I need to satisfy both quadratic. Right? So I need the gradient to be the same and the y-intercept to be the same. So I need some a value that satisfies both quadratic here. And if I look at the two sets of answers, it's only a equals to -2. That is the intersection between the two sets of answers for a. So I should have said more here to get full working out marks. So this is slightly not perfect, this response to question 2a. Okay, now we do 2b, finding values of a for which there is a unique solution. Unique solution just means this. Unique solution means if this is your first line, if I can draw, if this is your first line, then your second line looks like this, which means the gradients are different. And all we really care is the gradients are different. As long as the gradients are different, there is always going to be one unique solution, even if the y-intercept is the same, right? So even if you have, let me use a different color. Even if you have x-axis here, y-axis here, right properly, and then even if they have the same y-intercept, right? So that's the first line, and let's say the second line. Even if they have the same y-intercept, as long as the gradient is the same, it's gonna have one unique solution, right? So we don't. If you look at the format of the equations here, where y is the subject, we don't really care anything about the y-intercept. Even if they're the same or not, it doesn't really matter. It's just the gradient. We just need the gradient to be different, which is what I did here. I make the two gradients not equal to each other. Let me erase this. I'm making the two gradients not equal to each other. And then get my answer, which is a can be anything but -2 or 1. I'm basically recycling my result from question A, just make it not equal. Okay. Also, here's a kind of an important point. Well, trick really. The question gives you some hint actually, because the question says find the values, like S. So here, if you read your question carefully and you recognize the plural noun here, the noun value is in plural form. If you recognize that, then you know the answer you're looking for is multiple values for A. So it means if you get one answer for A, you know you're wrong. So it's not that powerful of a trick, but it just means that if you get one answer for A, then you know you're wrong. Similarly, in question C, value, if you look at that, it's a singular form, right? The noun value is singular, there's no S at the end, which means you're expecting one answer for A. If you are, if you end up getting more than one answer for A, you know you're wrong. So that's some hint for you. Okay, so here we need the lines to meet at a right angle. You are supposed to know that if two lines meet at a right angle, if they're meeting at a right angle, I can't erase this now. You are supposed to know that the two gradients multiply to give -1, which is what I did here. I take the two gradients of the two lines, multiply to give -1, and then there should be only one answer. Okay, moving on. I have a logarithm function here. D is the domain, but it's not given to us. Basically, it doesn't want to give you the domain. And then the first thing I do every time I see a function where the coefficient of x is not 1, in this case, the coefficient of x is -1, the first thing I do, I always do this, is I rewrite the function, but this time I take out the coefficient of x, which is -1, I factor it out, and then I make the coefficient of x 1, which means negative bracket x minus 2 bracket bracket. This step is very necessary because only after this step can I tell all the transformations of the function. Okay, and it's just state the maximum domain. Well, I actually did a little graph for myself with all the reflection and the translation and so on, just to put it down on the page to visualize it, and then I can say what the domain is. It says -infinity to 2, and then the brackets as well, it's not including 2, and it's not including -infinity. And then we need to sketch the graph, label the asymptote, and then axial intercept. And so here's the graph. You are supposed to know the translation. Translation is 2 units to the positive direction of the x-axis. And then you may or may not need to do some calculation to find the axial intercepts. That's what I did on the side here. And that's my graph. Also, when I did this, I didn't use a ruler. You need to use a ruler in the exam. You need to bring a ruler into your exam room. I did not, a bit sloppy here. And then it says find the values of x for which the y value is between 0 and 3. Well, you could visualize this. You could draw the line y equals to 3 somewhere, but it's not necessary. So I made it equal to 3 first. I made the function equal to 3, and then I get the x value. And I know that that's going to be the smaller x value because when the y value is 0, I'm over here. Right? When the y value is 0, I'm over here. And then when the y value is 3, I'm over here somewhere. So this is what I have. Yeah, this, if you will, I'm drawing a very rough graph, by the way. It's not to scale. It's not to scale. So that's y equals to 3 right there. So I know that this x value here is a smaller x value. And then when y equals to 0, I'm here, right? When y equals to 0, and that's a bigger x value. So when you do your answer, you need to take the bigger x value, put on the right, and the smaller x value, put on the left. So which one is bigger, which one is smaller, you need to be careful with this. And it's inclusive because of the equal sign in the question, the underline here. Let's erase that. Question 4. Again, I have a logarithm function, and I'm taking 2 out so that I make x coefficient 1. The coefficient of x has to be 1 for me to know what I'm dealing with. And then I've got an exponential. And then GOH, you need to show that GOH is defined for all x. For GOH, to just a reminder also, notation, GOH is GHX. So GOH means we are substituting H, the function H, into the function G. For this to exist, for you to be allowed to substitute function H into function G, you need the range of H to be a subset or equal to the domain of G. And then we're going to do this now. We're going to check if the range of H is a subset of domain G. So we write down what the range of H is. It's this one. It's exponential function. You're supposed to know the translation of it and how the graph looks like. So you know the range. And then the domain is given to us over here. The domain of G is given to us. And indeed, 2 to infinity is a subset of 3/2 to infinity. You can draw this on a number line. All right, so here's a number line. 3/2 is over here. 2 is over here. So you have this versus this. Form 2 is a bigger number, basically, is what I'm saying. So this is x over here. So 2 is a bigger number than 3 over 2. So 2 to infinity is a subset of 3 over 2 to infinity. It just means 3 over 2 to infinity is a larger set than 2 to infinity. So conclusion is range of H is a subset of domain of G. And then the conclusion is actually there can be one more line of working out. Therefore, if range of H is a subset of domain G, therefore the domain of GOH is the domain of H, which is the set R. So there can be one more line of working out. As long as the condition range of H is a subset of domain of G, we can conclude that the domain of GOH is the domain of H, which is R. It's written here, it's R. Therefore, GOH is defined for X. X is a subset of X is the element of real numbers. GOH. That. So let me complete my working out here. Okay, and then we're looking for range of GOH, given the domain is R. For this, I'm gonna actually write out the rule of the function, which is this. I'm substituting H into G. And then I realize I can't really draw this graph perfectly because it's not like a familiar type of graph in the study design of methods. So what I did was I drew G just by itself, and then I drew H just by itself, and then I'm substituting H into G, right? So I'm looking at all the Y value of H. The smallest Y value of H is 2. So if I sub 2, well, I need to rephrase. H never gets to Y value 2. The closest smallest Y value that H gets to, H gets infinitely close to 2 as a small number. So if I sub 2 into G, I get this, it's 0, which means the smallest value that G will approach is 0. Because the smallest value that H approaches is 2. If I sub 2 into G, I get the smallest value that G will approach, which is 0. Because if you look at G, the smaller the X value, the smaller the Y value. And then the bigger the X value, the bigger the Y value. So if I consider the smallest Y value on H and I sub it into G, I should get the smallest Y value of that, of GOH. And then I look at the biggest Y value of H, which is infinite. So it means I can sub infinitely big numbers into G, which means the Y value is going to get infinitely big also. So the Y value is infinitely big on GOH. And that's my answer. The range is 0 to infinity. Right, so all I'm looking at is I'm substituting the Y value of H into G. All right, and then what's the smallest H value? Put that in and check. And what's the biggest H value? Put that in and check. Put that into G and check. Because G is a one-to-one function. One-to-one function is easy to check. Okay, moving on. Question 5. This is a probability question. 90% of seeds will grow into seedlings. And then P hat is a sample proportion of seeds that will grow into seedlings for sample size 100. And then we need to find the mean and standard deviation of P hat. Well, if you don't actually understand or remember the theory, you could just use the formula sheet. I don't really want to explain the theory in this video. And so into this, the formula sheet at the end has a lot of stuff for sample proportion. One of them is the mean of p hat, which is just p. P is the proportion of the population. P is the true population data, statistic. So the population proportion is P, which is just the mean of the sample proportion. So you're just going to write down 0.9 because it's 90%. 90% is basically the P value, the population proportion, and it is just the expected value of the sample proportion. And with standard deviation also, standard deviation of the sample proportion also has a formula. It's in your formula sheet, so you could just use it. You take the population proportion, you times 1 minus P, and then over the sample size, right? N is the sample size. You're supposed to know how to use the formula, of course, and which means you're supposed to know what each letter means. And so N is a sample size, you put them in. This is exam 1, so you don't have a calculator. We put the numbers in. Hopefully you can do the arithmetic. 0.9 times 0.1 is 0.09. Divide by 100 is 0.0009. And hopefully you know the square root of that is 0.03. Hopefully. Because there are 4 decimal places here. So you know you need 2 decimal places, because 2 decimal places multiply 2 decimal places is 4 decimal places. You need to know that. And then 3 times 3 is 9. And then Z is the standard normal random variable. And by that, the question shouldn't even give you this. They're giving you this to make your life really easy, because you should know that standard, and here's I should have highlighted this in my working out. It's the word standard. Oh, hang on. It's the word standard. Right, standard normal. You should know that as long as the word standard comes out, it means the mean is 0 and the variance and standard deviation, they're both 1. It also tells you that bigger than -1 is 0.84. And every time I see something like this, I draw a graph for myself. Right? So on the Z scale, the standard normal scale, 0 is in the middle, bell curve. The peak is Z equals to 0. -1 is to the left, and it says Z bigger than -1. So from -1, I'm going to the right-hand side. All of that area is 0.84. Now, so I always draw this for myself on paper, not in my mind. And then we have a normal approximation of p hat for the sample of 100. At more than 93 seeds will grow into seedlings. Give your answer correctly to decimal places. Here, because the question is mentioning the standard normal, your first reaction or intuition is that you need to translate the sample proportion to a standard normal variable. And we can do that because we know the formula, hopefully. For any normal variable, normal random variable, because we are using a normal approximation, so p hat is a normal distribution. So for any normal distribution, normal random variable, you can convert it, I should say convert, not translate. You can convert any normal distribution to a standard normal distribution. Here it goes. So you take P, you write down P hat bigger than 0.93. The probability of that is equal to the probability of that, which is the standard normal, bigger than the number you're interested in, your P hat, which is 0.93. So you take the number 0.93, which is what you're interested in, because there's 93 seeds out of 100. So 93 out of 100 is 0.93. You take that number in which you're interested, you minus the mean. The mean is 0.9. That's from question A. And you divide that by the standard deviation. So basically, all we are doing here is we are measuring the distance between the number that we're interested in. We're measuring the distance between that number and the mean, but we are not doing the absolute distance. We are doing the distance as measured in the amount of standard deviation. So we're checking how many standard deviation is the actual number away from the mean. I repeat, we're just checking how many standard deviations is the actual number away from the mean. That's all we're doing. We do some calculation, that happens to be 1. But PRZ bigger than 1 is going to be equal to PRZ less than -1 because it's symmetrical, right? So in this graph here, let me actually draw it again. On the Z scale, Z is the standard normal, 0 is in the middle, -1 and 1, it's symmetrical. If I can draw my graph perfectly. So when I want Z bigger than 1, over here, this is the area. Z less than -1 should be the same area. It's a symmetrical graph, which means if I need to know Z less than -1, all I need to do is 1 minus Z bigger than -1, which is what the question gave me. So Z bigger than -1 is 0.84, 1 minus that is 0.16. So my final answer is 0.16. Erase that. All right. Moving on. Question 6 here. It's a sine graph. Again, my first reaction is to make the coefficient of x1. So I factor out the 2 and I write it down. Here's the graph. It's a nice question. It gives us the graph. We need to use the trapezium rule to approximate the area under the graph between the, bounded by the graph of G, the x-axis, and the line pi over 6 and 2 pi over 3. Well, trapezium area approximation, the formula is in the formula sheet. It's this one here. You just need to know what and how to use the formula. Xn is the rightmost x value, which is 2 pi over 3. X0 is the leftmost x value, which is pi over 6. 2n, n is the amount of trapezium. So here we have 3 trapezium. You can see my highlighting here. You always need to highlight keywords. We're doing 3 trapezium, so n is 3, 2 times 3 is 6. That's where my 6 comes from. And then you just plug it in, right? So f, you sub the leftmost x value, plus 2 times the next x value, plus 2 times the next x value, and then you plus f, you substitute the last x value. And this is what I did here. And basically the graph that the question provided to you gives you the numbers that you need to sub in, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And I kind of made a mistake here. I tried to substitute pi over 6 into the actual function to calculate the value. So here, when I write down the formula, I wanted to figure out what the pi over 6 is. So I actually started to do a manual calculation that is completely not necessary because, like, as soon as I wrote that down, I thought this can't be it. For 2 marks, the question cannot be asking me to perform this much work. I need to find 4 trigonometric values, and that's a little bit crazy. And I realized the graph gives you the answer, right? So if you go to pi over 6, you can just look at the y value, which is 1. And if you go to pi over 3, you look at the graph and it's 1.5, and you times 2, so it's 3. So on and so forth, right? So the question actually gives you all the y values, or the g values here. And you just look at the graph and write them down. And pi over 2 is 2.5. If you times 2, that's going to be 5. And then do my calculation, and that's it. Don't forget unit square, because it's looking for the area, so you want to include the unit. And then we're transforming, we're doing a dilation on the graph of G, and there is a domain here. And it says using calculus, find k such that k is a probability density function. All we are really doing is we take the function k times g, but I'm putting k outside just to make it easier. You're allowed to do this when you are integrating. When you're integrating a constant times a function, you can put the constant outside the integral sign and just integrate the function. The terminals are pi over 6 and 2 pi over 3 on the integral. Integrate that has to be 1. You're supposed to know that the definition of probability density function is that if you integrate over the domain, it is going to be 1. And so it says using calculus. So I'm going to do that. I'm doing this by hand. Hopefully you know how to integrate a sine function. If you do not, remember, again, integrating a sine function is in the formula sheet, so you could just follow the formula. So integrate the sine function, I get this. There's 2 here also, so it becomes 2x, and then sub the values in, minus in between, which means this negative sign becomes a plus over here. That's all equal to 1, and then do my calculation, k is equal to 1 over pi. You can pause the video to have a look at the working out here. So that's done. Question 7, another probability question. X is a discrete random variable. The probability density function is 2 over 3 to the power of x. X is a positive integer, so it can't be 0, can't be negative, can't be decimal. It's an integer and it's positive. That is integer. Plus means positive. And so probability of x equals to 4 is you just sub 4 into the function. So that is the answer. And then a conditional probability question, which is quite straightforward. You're just going into the formula for conditional probability. I think that's also in the formula sheet. So if you ever forget the formula for conditional probability, it's here. If you memorize it, it's better. But the intersection between x less than 4 and x bigger than or equal to 2 is just this. If you need, you can draw a number line. So x less than 4 is this one here, open circle to the left. And then x bigger than or equal to 2 is this one, closed circle to the right. The intersection between them is literally where they overlap, but it's discrete, so there's no decimal. You could write 3 down and then the equal sign as well, but I'm just doing this. 2 less than or equal to x less than 4 over x bigger than or equal to 2, and then you do a calculation here. This is when x is 2, when x is 3. You don't need to do x equals to 4. And for this one, it is x bigger than or equal to 2, which means you're just excluding the case when x is 1. All you're doing is excluding when x equals to 1. So 1 minus the probability of x equals to 1. Calculation, hopefully I did this correctly, and then that's the answer. Again, if I made a mistake in my arithmetic, please leave that in the comment section. Question 8, a function with a domain. It's a square root function, but it's 1 over square root. Well, actually, I'm going to take it back. It's not a square root function. It's 1 over square root. And then I need to find the antidiff. Well, again, if you forget, well, the first step you can't really forget. You have to get the first step yourself. It's not on the formula sheet. Because you need to write a fraction in terms of a power, a negative power. So almost always, if you have 1 over something x, 1 over something that involves x, you always write it in terms of a negative power. Once you do that, if you forget how to antidiff this, it's also okay, because I think this is also in the formula sheet right here. This is also in the formula sheet. Look, something x to the power, it's linear, by the way, it has to be a linear function inside brackets. A linear function to the power of n, as long as n is not -1, you can follow the formula here. The power is -½ It's not -1, so I can follow the formula. So if you did follow the formula, you get this. And also, let me highlight. It says find. I should highlight this. Find n antiderivative, which means you don't need c. You do not need. You don't need your plus c anyway. Plus c is if you write plus c, it means you're writing down the general antiderivative. It is plus c means any derivative. That's not what the question is saying. The question is saying find an antiderivative. So it needs a particular specific case, which means you could write +1, you could write +2, you could write -5, you could write minus pi, you could write plus e. They all work. It is an antiderivative, so I'm just using +0. And then it says the average value of the function over some domain is 1/3. find the value of m, where m is the end of the domain. It's one end of the domain. And you are supposed to know the formula for average value. Is that on the formula sheet? I don't think so. Yeah, you're supposed to know the formula for average value, which is not a memorization. You basically imagine the area is a rectangle, and you divide by the width, the horizontal width of the rectangle, and then the height is the height of the rectangle is the average value. So that's what we're gonna do. The horizontal length is from 0 to m, so 1 over m, where we're dividing the horizontal length. And then the area of the rectangle is from 0 to m. We entity of the function, and it's gonna be, the area has to be 1/3. So do your calculation. Basically, first thing I'm doing is I multiply m on both sides. So m over 3 is really on the right hand side, but I'm writing it on the left hand side. And then that's what m over 3 comes from. M over 3 comes from multiplying both sides by m. So m over 3 is on the right hand side, but then I'm going to write it on the left. And then I antidiff this, which means 2 over 3 square root of 3x plus 1. But I am substituting m into my antidiff, minus substitute 0 into the antidiff. So I get this. This step is after I antidiff and I substitute m minus substitute 0. And then clean everything up, times 3 on both sides, and then move things around. Eventually, I'm going to get a quadratic. And then move things around again, make one side equal to 0, factorize, get the answer. But the question says 0 less than or equal to x less than or equal to m, which means the question will not make sense if m is 0. I mean, if m is 0, there is no area. Right? If m is 0, the area can't be 1 over 3. The area is just going to be 0. Because the two boundaries of the area will be one single line, one and the same line. So you can't have two boundaries of a shape to be the same line. Otherwise, the area is 0. So m can't be 0, which means m is 8. Almost there. 2 more pages. This is a slightly complicated function. It is a linear function times a exponential. First question is diff, so use product rule to diff it. And then this is a kind of a crazy question. State a sequence of transformation that map f onto f dash. Well, you can see what I did here. Actually, you can't. I'm going to explain what I did in question A. When I did question A, the first step is just following the formula for product rule. I got that. And then I actually stopped here. Right? So this is, when I first did question A, I actually stopped here. I stopped on this step here because that is the answer, right? That's the everything simplified and so on. I didn't factorize it, so factorize this, simplify, and then that's the answer for the derivative. And then I basically didn't have that line there. When I first did question A, I didn't have that line there, and then I went on to question B, and then the problem starts. If you look at F and you look at F dash, as I wrote first time, ignore the part I've crossed out, I realized the problem that I have. The problem is, okay, first I realized something nice that I've done. What is nice about what I've done is I factorized my derivative, which is something necessary. If you did question A and you wrote this down and that's your final line, if that's your final line, that's fine. If this was your final answer for question, I can't really write on my screen. If this is the final answer for question A, you should get the mark. You should get the 1 mark here. That should be all okay. Okay, this is fine. But I realized that what I did with the factorizing is actually a blessing for question B, because if you look at question A, sorry, if you look at function f and f dash, I need to transform f into f dash. And notice how f is factorized. Right? F is not expanded, f is factorized. So if I wanted to make my job easier, I should factorize f dash also, because if f, basically I need to make f dash look like f, right? I'm transforming f to make f dash, so somehow I need to make f dash look like f to make my job easier, to see the transformation better. So if one function is factorized and the other function is expanded, it is very difficult to make them look alike, therefore very difficult to spot the transformation. So that's the first insight. You should factorize f dash because f is factorized. And then if both are factorized, it makes it much more easier to spot the transformations between them because they look alike. If one is factorized, one is expanded, it's very difficult to see the similarities and differences between the two functions. So that's the first thing. And then, so factorize is good, but then I realized there's something else that's bothering me, because in function f, first time x appears, it's a positive x. Second time x appears, it's a negative. So the sign between the first x and the second x appears twice. The sign between the first x and the second x, signs are opposite. Which means if I do a translation in the direction of the x-axis, it's not going to change the sign. Right? If I translate function f, the two x values are still going to have opposite signs. And if I for dilation, if I substitute negative x into my function, if I do this, if I substitute negative x into my function, it is also going to be opposite sign. Right? So if I substitute negative x into my function, I'm going to get opposite sign also, opposite negative x and then positive x. And that's a problem because with my first answer for question A, the signs of x are the same. So the first time x appears is negative. The second time x appears is also negative. And so superficially, at least on surface, there is no obvious translation or dilation or reflection that can make f. I can use to transform f into f dash, because the signs of x are not matching. So to fix that, f, in the function f, the signs of x are opposite. To fix that, this is how this is why I did the final line in question A. Right? The reason that I added the final line in my response to A is it's just that I want the signs for x value to be opposite in my f dash also, to make f dash look more closely like function f. So what I did was I don't want to mess with e to the power of negative x because that's simplified enough, and that is also what f has. So what I want is I'm gonna take the negative. I'm gonna take the negative 1 really. I'm gonna take the negative 1 as a factor out of negative x plus 2. And so if I factor out negative 1 in negative x plus 2, I get negative sign in front of the whole thing. And then in bracket, I just get x minus 2. I just reverse the sign of everything inside bracket. And now I'm looking kind of nice because negative x, positive x in my f dash, and then negative x, positive x in my f, and then it's e to the power of negative x, and then it's e to the power of negative x. So that's good. And then difference is the negative sign, and the difference is the x minus 2 versus x minus 1. And here's my working out. So the first thing I wanted to make was I wanted to make x minus 1 become x minus 2. I want x minus 1 to become x minus 2. And that's what I did. I did sub x. If I sub x minus 1 into f, I get x minus 2, right? Because it's x minus 1 minus 1 if I sub x minus 1 into f. So I get x minus 2 here, but then the power of e is changing also because it's negative x here. So if I sub x minus 1 in, it's going to be negative x plus 1. But if I have, so basically x minus 2, I have achieved that already. I've achieved x minus 2. But whenever you see a power that is something plus something, you can react by splitting the power. So this is index law. If the index is something plus something, you can write this as e to the power of negative x times e to the power of 1. This is really power of 1. I should put that here just for explanation purposes. Power of 1. So it's negative x plus 1 if you do index law, but then you can go the other way. You can split them, and e to the negative x times e to the power of 1. And if you compare this to f dash, because I need to transform f to f dash, so I want whatever I do to f, after I do stuff to f, I want it to look like f dash. So the only difference between f and f dash now, I've got e negative x, I've got e negative x, I've got x minus 2, I've got x minus 2. The difference is the e here, e to the power of 1, and the negative. So I'll do this. I take this function f x minus 1, and I multiply this by negative 1 over e, because if I multiply the function by negative 1 over e, e and 1 over e cancel out. Negative comes to the front. Right? So negative is just negative. You stick that in front of the rule of the function, and then 1 over e cancels out with e. And so this now look exactly like f dash. Right? So and I take f, translate, dilate, reflect, and then I get the exact same rule as f dash. And so here, when you write down your answer, the order of what you write kind of matters. Actually, in this case, it doesn't really, because you're not moving in the y direction. We're not translating in the y direction. So you could get away with the ordering of things, the order of the transformations that you write down. But I'm just sticking to the way I thought about this. So translation comes first, and you need the right language. It's 1 unit in the positive direction of the x-axis because it's x minus 1. And then reflection in the x-axis, and then dilation of factor 1 over e from the x-axis. Okay, and also reflection and dilation, it really doesn't matter what order you put them in. And then in this case, really, it doesn't matter even if you put translation last, because the translation affects the x value and reflection and dilation affects the y value. So all the types of transformations that we're dealing with here means that you could get away with writing them in the wrong order. All right, so we've got a differentiation question again. So it's negative x times e to the power of negative x, and you diff that. Again, this is a product rule, so you just apply the formula for product rule, and you do your arithmetic. Hopefully, I'm doing this correctly, and then you conclude that it is the same as fx. And then question D, we're still in the same question. Function g is a straight line. It is a tangent to a function f at the point 3. And then using the derivative of negative x e to the power of negative x, we need the area of the region bounded by the line x equals to 1, g, and f. Well, it just means to find the area, it means we need to integrate, but the integration terminals are 1 and 3. It's literally given to you in the graph. And then we need it's area between two graphs. So the top graph minus the bottom graph is what we need. So G minus F. To do this, I kind of need to find the equation of G first. So I look for the gradient of G, which is the derivative of F when X is 3. And then I put the gradient into a straight line form, plus C. And then this C value, I need to find it by looking at a point that the graph G goes through, but the point that the tangent goes through is the point on the graph F when x equals to 3. So I calculated that. When f is 3, the y value is 2e to the power of negative 3. What that means, so y value 2 times e to the negative 3, and then x value is 3. So that means to find c, and then I construct the actual g function, and then I antidiff g function, and then I get this. Because it's a straight line, it's kind of okay to antidiff. So the integration becomes this giant thing, which is fine. Integrate g, I get this. It's an integration of a straight line, so it becomes a quadratic. And then integrate f, well, this is what question C is doing. Question C is actually giving us a hint. It's giving us a hint. For question D, the purpose isn't really to test product rule over and over again. It is just to give us a hint for question D, because if you differentiate this thing to give f and you antidiff, it just means if you antidiff f function, you get negative x e to the power of negative x. So I can antidiff f, but I don't really antidiff f manually. The question tells me the answer of antidiff f, so I just do that. But it's a minus, so there's a minus here. So I need to change it into a plus. And then sub the numbers in, sub 3 in, and then you minus whatever you get when you substitute 1 in. Well, let me put it a different way. You sub 3 in, and then you sub 1 in, and you minus in between. And you do some calculation, and you get this. Again, if you find mistakes in my arithmetic, in my calculation, please leave it in the comment section below. And the answer I got is 9e to the negative 3 minus e to the power of negative 1 unit square. And that is all. Yeah, that is everything I want to talk about regarding exam 1. Thank you for watching.